Hey guys, my name is Yashraj and I am here to give a small presentation on the topic tidal energy along with my members Sanket Gurav, Prathamesh Koli, Chinar Metil, Prajwal Madiwal and Gazal Momin. So let's start with the introduction of topic tidal energy. So tidal energy is also known as tidal power. It is a form of hydropower that converts the energy of tides into useful form of energy, mainly electricity. So this is the form of energy whose source is the moon and only source is the moon. So tidal energy requires two sources. The primary source is obviously the water and secondary source is the moon. Till the sources water and the moon exist for earth, we can use this tidal energy for producing the electricity. Okay, but what is the physics of tides? I mean, how it is created? So as I said, the moon is the secondary source. This is the reason why the tides are created. So the gravitational pull of the sun and the moon and the pull of the centrifugal force of the rotation of the earth-moon system is responsible for creating the tide. When the landmass lines up with the earth-moon system, the water around it creates a high tide. If the landmass is at 90 degrees to the earth-moon system, then the water around it is at low tide. There are two high tides and two low tides are created during each period of rotation of the earth. Okay, so these are some of the facts about the tides. Spring and neap tides depends on the orientation of the sun, moon and the earth. Second, high spring tides occurs when the sun and the moon lines up with the earth. This occurs whether they are either on same or opposite side. Low neap tides occurs when the sun and the moon lines up at 90 degrees to each other. Flood currents. The currents moving in the direction of the coast are flood currents. EBB currents. The currents which are receding from the coast are known as EBB currents. Now I request Master Prajwal Madiwal to continue with the further slides. Thank you.
Hello friends, my name is Prajwal Madiwal. I am talking about the history of the tidal energy. The process of following water and the spinning turbines are used to create electricity. It is introduced in Europe and US in 19th century. Tidal plants are only installed along the coastlines. The first tidal power station was installed in the Reims. It is in France. It takes six years to install one power station. It is named as tidal power station. It generates 250 megawatt power by 24 turbines, and it supplies 0.012% of power demand by the France. This tidal power station is built on the Reims River. It has 750 meter length and it has 24 turbines in the power station. India's first tidal power station built in Gujarat by name of Gulf of Kutch. Now we are talking about the turbines of the tidal energy. The turbines play most important role in generating electricity. With the help of turbines, can rotate the kinetic energy of the ocean into electricity. It is the renewable resources. The tidal turbines are similar to the windmills, but the ocean water has 800 times more density than the water, so it takes easy to rotate the turbines. Electricity generate easily in the tidal energy. Tidal energy can produce in rivers, in streams and or other man-made waterways. The tidal energy power stations are easy to install. It is recyclable and no pollution occurs.
Myself, roll number H25. So I will be explaining the types of turbines to you. So basically in our presentation we have included three types of turbines. First one is axial flow turbine, second one will be cross flow turbine, and third will be barrage turbine. So I will be explaining the first two types, that are axial flow turbine and cross flow turbine. Let's start with the axial flow turbine. An axial flow turbine is also known as a horizontal axis turbine. So why horizontal axis turbine? The reason behind this is that the axis of axial flow turbine is always parallel to the flow of fluid. Consider this as the flow of fluid or flow of water. So it moves from left to right. So let us consider this as your turbines. For an example, consider this as the axis of the turbine and this as the rotors. So if this is the flow of water or fluid, then your turbine will be rotating like this. So this axis, which is parallel to the flow of fluid, is known as the axis of turbine. So you can compare this type of turbine to the exhaust you see in different malls and all. This exhaust works to remove the hot air from the room to the outside. These type of turbines are used to convert the pressure energy and kinetic energy of fluid into mechanical energy, and this mechanical energy is ultimately converted into electrical energy through a generator. The subdivisions that an axial flow turbine has are inclined axis, uh, rigid mooring, non-submerged generator, and a submerged generator. Non-submerged generator means the generator which lies above the fluid, not inside the fluid. So this was an axial flow turbine. So next point I will be explaining is a cross flow turbine. Cross flow turbine is also known as a vertical axis turbine. Why? We'll consider this as our turbine, consider this as the flow of fluid. So ultimately this will become the axis of your turbine, and these will be the rotors. When the fluid will flow from left to right, your turbine will start rotating in this manner. So this axis is vertical or perpendicular to the direction of flow of the fluid. Hence it is known as a vertical axis turbine. This turbine is also used to convert the kinetic energy of the fluid to mechanical energy and ultimately into electrical energy through the help of a generator. So these turbines are also known as floating motor wheels. These are mainly drag based device. So discussing about efficiency, cross flow turbines generally produce lot of energy in as compared to axial turbines. This is mainly because all the energy of the kinetic energy of the fluid is directly converted into rotational motion in cross flow turbines, whereas in axial turbines not the whole of the kinetic energy can be converted into rotational energy due to some limitations in the flow of water through the turbines. So that's it from my presentation. Myself, roll number H25.
Hello everyone, myself Prathamesh Koli, roll number H33. Now we are going to discuss about the types of the basins. So generally there are the two types of basins, single basin generator and double basin system. Single basin generator includes EBV generation, fluid generation and two-way generation. EBV generation. EBV generation uses the gates that allow the water to fill the basin. These gates are closed during the time of the full tide and kept closed until the tide has left sufficiently so that the turbine starts spinning and it results into the generation of the electricity. Fluid generation. In the fluid generation, basin is filled through the turbines generated at the time of the tide. The fluid generation is less efficient as compared to the EBV generation. Two-way generation. In a two-way generation, the sluice gates and turbines are kept closed until the half of the tide, and when the water is allowed to flow through the turbines, it results in the generation of the electricity. But when the hydrostatic head is insufficient for the power generation, the gates are kept open and it kept open until the high tide, and when the water is allowed to flow out of the basin through the turbines, it results again into generation of the electricity. Double basin system. In the double basin system there are two basins, but the operation is similar to the EBV generation single basin system. The only difference is the proportion of the electricity generated is used for the pumping of the water into the second basin, allowing storage. Let's talk about the advantages of the tidal energy. First of all, it is the inexhaustible source of the energy. It is the environmental friendly energy and it does not create any type of the greenhouse gases. As we know, 71% of the earth's surface is covered by the water. We can create the tidal energy on a very large scale. Efficiency of the tidal energy is far better as compared to the solar, wind and coal energy. The efficiency is almost around 80%. Tidal energy does not require any type of fuel to run. The lifespan of the tidal energy plant is so long. Due to the high density of the water, almost 1000 times of the water, we can create the large amount of the energy from the very slow tidal streams. Thank you.
Myself Gazal Momin, roll number H45. So let's discuss the conclusion of tidal energy. The actual generation of tidal energy is for a very short period of time. This time only happens twice a day. So electricity can be produced only for that time. Usually the places where electricity is produced is far away from the places where it is consumed. This transmission is effective and difficult. Tidal energy industry has to develop a new generation of efficient, low cost and environmental friendly apparatus for power generation from far or ultra low headwater flow. The negative environmental impacts such as tidal wages are much smaller than other sources of electricity. It is important to consider the influence of energy extraction while estimating the available energy from a potential tidal energy site. The further cost of other sources of electricity and concern over the environmental will ultimately determine whether humankind extensively harness the gravitational power of the moon. As yet, the majority of tidal energy resources is underutilized. However, if effectively captured using suitably engineered system, it could capable of making a major contribution to our future energy needs. Thank you.